This is another of our occasional video podcasts, so bear with us as we try to fine tune the process. As our co host today, we have Mike Harsh, a friend and overall good techie that spends his life in edge IoT and sometimes on crypto. We have with us here today Jonmichael Hands, VP of Storage at Chia Project. So, Jonmichael, why don't you tell us a little bit about yourself and what's new at the Chia Project?
So I joined Chia in May of 2021. Prior to that, I had been at Intel for 10 years in the non-volatile memory solutions group doing SSD development, product management, product marketing, kind of you name it for the SSD product line at Intel. As you guys probably are aware, in 2021, that whole business unit ended up getting sold off to SK Hynix, and that's now Saladigm. And after that, so I went over to Chia around early 2021 during this whole crypto craze. And if you guys remember Chia in 2021, it was pretty
Hot
interesting hit to
product.
the storage
Yeah.
market. I don't know if you guys remember kind of what happened, but yeah, we like sold out all of hard drives in China, and then pretty much shortly after US. And hard drive prices got all the way up to like I think 4 or 5 cents per gigabyte, which is like now if people that know that storage is kind of like what like cheap NVMe drives are today, like consumer drives you can buy for the same price. So it was pretty wild times. And obviously the crypto markets was pretty nuts back then. But yeah, Chia is still chugging along. We've actually made a tremendous amount of progress in the last 2 years. It's been so really just actually bringing on all the actual functional capability of the blockchain.
Yeah,
We
Chia
absolutely
is a
talk lots
bit of a
about that.
bright spot in the crypto space these days. I mean, everything else is kind of having a real serious problem, but Chia seems to be chugging along, I guess. Wouldn't you say, Jonmichael?
Yeah, so if you go to the website, you'll see secure, sustainable, and compliant is kind of our positioning of the blockchain. And those are really important things, right? Like, so people like Bitcoin, but obviously consumes a tremendous amount of energy, and that's not good. So that was part of the reason why we started Chia was how can we make a blockchain that's as we're more decentralized than Bitcoin, completely decentralized, peer-to-peer, permissionless network, so anybody can join when they want to and leave. This is something we call Nakamoto consensus, which is you don't really trust anybody. You just trust whatever the longest blockchain is. And so we said, okay, how can we do this without using a tremendous amount of energy like Bitcoin? And that's kind of how we stumbled on storage. And then, the compliance thing, which has been obviously top of mind for everybody in the crypto space, is a lot of these companies that sold unregistered security offerings and were just outright Ponzi schemes are now getting cracked down on by the SEC. This was kind of our thesis in 2021, as we're if you read our like public white paper and strategy, we've always wanted to file for an IPO and be a regulatory compliant offering and be publicly traded. And it would be the first crypto company to be publicly traded
Oh God, yeah.
in the sense that we have a native crypto asset on the balance sheet. So that's
Huh.
obviously a pretty big undertaking, right?
So, in order to be compliant, you have to do regular accounting and all this other stuff. I mean, you have to have actual organization behind it, some sort of, I don't know, C corp or S corp or L corp or whatever, don't you? I mean, it's not an easy process to be compliant to that sort of stuff, right?
No, it certainly isn't. And yeah, thankfully, our CEO and CFO have done this before with other public companies. Our new CEO, Gene Hoffman, is very experienced in the space. So he started
That's
eMusic
amazing.
and other popular things. So he's done this stuff before. So
So,
Yeah, that's
can
amazing.
we dive in a little bit to the value proposition of Chia in terms of like energy? So, um, is it fair to say that the way Chia works is by um, replacing the proof of work load on the network um, with a different proof of work that uses a lot less energy and is has kind of a longer tail of uh, so the goal of Chia is to have the same or better security, but with much less embedded energy in the network. Is that
yeah,
kind of
yeah.
fair
So
to
there's
say?
this. Chia uses a consensus called proof of space and time. Our founder, Bram Cohen, is most famous for inventing BitTorrent. Right, this is this peer-to-peer file sharing network. And a lot of these same principles that made BitTorrent really successful are some of the core ideas in, that are in crypto, this fully decentralized peer-to-peer. And it's actually not a secret. Bitcoin is an homage to BitTorrent, this whole idea of the naming of Bitcoin. So the idea was so Bram had this hypothesis that, one, he's like, so it seems like there's a lot of storage out there. The whole idea with Bitcoin was supposed to be this one CPU, one vote. And obviously that devolved into these single purpose ASICs that all they do is SHA-256 to mine Bitcoin. They consume a lot of energy, create a lot of e-waste. That's bad. But storage is, a terabyte is a terabyte. Obviously there's different latency, and everybody in the storage world knows these memory pyramids, which is, you pay more money for storage media that has faster, lower latency, like DRAM and SSDs, hard drives. But the actual space is actually a really nice commodity, because the way that we do our proof of space in Chia is you don't get any benefit from extra latency. So if you have a terabyte of SSD or a terabyte of hard drive, you're just earning rewards for 1 terabyte of storage. And IDC has this nice report called the Age of the Data Sphere, which basically says, here's all the data in the world that's created, here's all the data in the world that's stored. And then they have this graph of like how much of that is underutilized. And I think in 2020, maybe it was 2022, it was like 8 zettabytes of storage. There's like over 3 zettabytes of underutilized space. So that's one good thing. Like, okay, there's a lot of storage out there. The other thing we're doing is focusing on the circular economy, which is like getting used storage back into the crypto market. So today, unfortunately, what happens is if a hyperscaler like, say Microsoft or Meta or something uses a hard drive, they use it for their 5-year life cycle. And then at the end of that, when they decommission it, they do this encryption, full media sanitization on it, and then they throw it into a shredder because of data privacy concerns. And so one of the big ideas for Chia was like, hey, can you guys stop doing that? Let's stop destroying all the storage, and then we can get it back and recycled back into this market. And crypto is a really nice, interesting use case for this, like, used hard drives where, you don't really care. It doesn't store user data. We just store cryptographic hashes on these hard drives. So, you can use any quality of media, like used hard drives are perfect.
So you referenced in one of the emails to me, Jonmichael, the IEEE paper that you did, I think, with Tom on the your repurposing of storage and things of that nature. I didn't I have to admit I didn't quite finish the paper, but it seemed like it's an interesting approach to doing things differently than shredding all your magnetic drives and things of that nature.
I've been spending a tremendous amount of time over the last year and a half in the sustainability space, a lot around circularity. So we have, many of you guys maybe know the Open Compute Project. So there's a new sustainability project, which I'm heavily involved in. We released a white paper last July on media sanitization of the circular economy. I've been working with folks like Meta and Microsoft and Google, the chair of those work groups, to kind of get these standards. We started a new nonprofit called the Circular Drive Initiative, where we have Chia, McDonough Innovation, Micron, Western Digital, Seagate, and a bunch of other storage vendors in this work group, basically trying to solve circularity and storage. And then, as you mentioned, I'm part of this IEEE Security and Storage Working Group, where we actually created the brand new specification on media sanitization. It's called IEEE 2883-2022. And this basically describes some methods to basically be able to securely remove all the data on a drive, completely enabling reuse. The ones that people are common, people used to call this like secure erase, or people call it wiping or erasing and shredding. Well, we have a specific scientific word for it. It's called sanitization. And this is the process of rendering the target data on a target device inaccessible for a given level of effort. So these purge media sanitizations are actually secure versus nation states, and which is surprising to people. You don't need to buy fancy software to do this. The firmware in every single modern hard drive and SSD actually supports sanitize command by default. So,
that's amazing.
But how can you trust it?
Yeah, and this is the $1 million question. Yeah, this is So there's for the majority of people, you basically can write. There's something called verification of sanitization. So there's 2 camps here, right? One is that you can do some forensic auditing and actually if you're actually certifying for like a FIPS 140-3 certification, they actually look at the firmware implementation for sanitization of like, is the key wrappings and encryption methods the right standards? Is the firmware operating properly? But realistic verification is you write a known data pattern to the drive, issue these erase commands, and in a crypto erase, for instance, you're just changing the media encryption key on the SSD or hard drive. Some of the hard drive vendors call this like sanitized instant erase, or ICE or whatever. It's called crypto erase, and sanitize is what the official name of it is. But you're basically just changing out the media encryption key, and then when you read all that data back, it's just going to be random data because you've changed the encryption key and all the data is still on the drive. You've thrown away the key. So if you write a known pattern to the drive, do a crypto erase, and then read the data back, you're not going to get the same data. And so
it works well for encrypted drives, but I don't know if it works well for non-encrypted drives. I guess most of the hyperscalers probably use encrypted.
Yeah, so for hard drives, they basically segment these out, and in the future there will be So if you guys have paid attention to what's going on in the storage world, obviously, as you're well aware, the consumer hard drive market's kind of dying in favor of SSDs, and most of the hard drive business is going to these hyperscale type drives, and it's there won't be some giant premium for these types of drives. Thankfully, on SSDs, all the SSD controllers basically do AES 256 scrambling on the controller, regardless of whether there's an encryption key set, like there's something like Trusted Computing Group or something like that. They do this actually to scramble the data before it hits the NAND, because NAND doesn't like data that's
patterns.
Pattern. Yeah. So any SSD used to be like NVMe format or something like that for some of the very first generation drives, but basically any drive after 2017 that supports NVMe 1.3 or greater will support this sanitize command.
Amazing.
Yeah. But yeah, these little things, getting this data out to the world is why we're writing these white papers and starting these initiatives. And that trust thing is like the really hard part, because trust at a hyperscaler that has zero tolerance for data leaking, right? Like Meta or Microsoft, they're not going to allow somebody to go to eBay and buy a drive that used to have customer data on there. That's not happening, right? So that's a little bit more challenging, right? Where they need to have hardware roots of trust and firmware attestation and all this encryption for data in flight and at rest, and lots of other things added to that stack to where they feel comfortable. Versus like, if I'm selling a drive on Craigslist or something, I can just pop the drive in a machine, run the sanitize command 2 seconds later, and I'm fairly sure all the data's gone.
Right.
So if you're successful in implementing these initiatives, what's the vision of the life cycle of a drive, like between now and like when hard drives are obsolete? Is it just a matter of extending the useful life?
Hard drives ever go obsolete, Mike? I mean, that's a whole different question. I'm sorry. Go ahead.
Yeah, it's just they go down the storage stack, right, to where, and we're already kind of seeing that where hard drives are still used for what like Meta or other folks call warm storage, which is like frequently access blob storage. That's the majority of their data, which is like stuff accessed within a couple months, pictures, videos, whatever. The ideal life cycle of these drives, right? The reliability of hard drives and SSDs is actually extremely well understood. It was funny. I worked in the corporate reliability department at Intel for a long time as well, and early in my career in the validation. And you have these Paretos, and the annual failure rate and the annual return rate of drives. And I mean, for some of the most popular Intel SSDs that had 5 to 6 million units shipped in their lifetime, after like 2 to 3 firmware updates, because a lot of SSD failures are actually around firmware. The AFR was actually like 1/2 of the rated publicly listed AFR. So it was like 0.02%, like it was like 0.2% AFR. And actually some models got down to like 0.1%. And most customers are not using the full endurance of the drive. We found NetApp has this really nice study where they took like 1.6 million drives in the field, and they had their telemetry running on the NetApp software that give all the feedback of the smart of the drives. And they found out that the overwhelming majority, 95% of the drives were like less than 5% used after a full 5-year life cycle. So for SSDs that can last 10, 15, even longer, right? There's AWS instances that are running some of the very first Intel SSDs and spot instances right now. That's 11 years, 12 years after. I mean, so the life cycle of these drives is well above 5 years, and everybody knows that, right? You can buy a drive on eBay, right? There's Intel drives that I worked on 10, 11 years ago on eBay that are selling right now, and they work just fine. Which so yeah, the idea around the circular economy is this: you cycle them from one value chain to another. Like so, one hyperscale will use them 3 to 5 years, and they may have a benefit to go to a higher capacity drive or denser storage or better TCO. But once they're done with that, the idea is instead of shredding them, they can securely sanitize them and then get them to one of these other use cases, whether they're selling these to a distributor or to a crypto farm or anything else. The idea is that now these can get another 4 to 5 years of useful life before they finally break, and then because they didn't have any user data on them in this crypto use case, then they can safely send them back to Seagate or Western Digital or whoever the vendor is for recycling all the components. The magnetic, like hard drives especially, have these rare earth materials in the magnets. So you definitely don't want to be putting those in the landfill. And SSDs is even worse because obviously it takes a tremendous amount of electricity and water in these giant fabs to create the NAND wafers. And so the idea of just taking a perfectly good drive and hucking it in a shredder is it's very sad to me, right? When there's a ton of use cases for that storage elsewhere. So,
so
Chia is one of the main use cases for this sort of storage. I mean, from a crypto perspective,
that's the idea. Right now we have like a little 24 exabytes of storage on the Chia net space. At the peak, I think it was around 48 exabytes, which was like, in 2021 was like 3% of global hard drive sales, right? So it was a pretty big chunk. We'll just say when Chia's the top 10 coin, okay, if we're getting wishful thinking here, but if we're a top project and being used to secure global finance, it is very realistic that we'll see 300 or 400 exabytes of storage in the Chia network. And I'm working very hard in my job to make sure that we ethically and sustainably source that storage. One, because I just told you it already exists. Like we know that this storage is out there and it's just getting destroyed. And so that's the big, unpleasant part of this whole thing is we want to be able to sustainably grow and do this in a way that not only is securing our network and making it impervious to attacks, and basically having the once we have a 300 or 400 exabyte net space, that we're going to be completely impervious to any nation state attacks. Nobody's going to be able to just buy 300 exabytes. You know what I mean? So and we know the storage is out there, either being underutilized or being destroyed. So that's the end goal. So
isn't Chia already a very distributed environment? I mean, it seems like it's got more. I don't know if the right term is farmers or harvesters than any other equivalent crypto coins or that sort of thing. I mean, like you said, Bitcoins are all ASIC. The big guys are all ASIC driven, and and that's about it. It's almost to the point where if you control the ASICs, you could control Bitcoin to a large extent.
Yeah, so in the crypto world, in Chia we have farmers, not miners. As thank you, Ray, you perfectly touched on. And again, we called it farming because you're not putting a bunch of continuous energy on there. You basically make these plot files. These are like cryptographic 100 gigabyte files. You copy them on to the hard drive, and then they basically just sit there idle. A drive farming Chia today is 99.7% idle. So it's like basically the easiest workload. It's Ray, for you storage guys, it's 0.5 IOPS is the crypto is the read in its read only workload. So it's about the easiest workload a drive will ever see in its life.
So a half a IO a second, effectively, is what you're saying.
That's it. Yeah, on a modern hard drive, it's a couple kilobytes a second. It's nothing.
Yeah.
And so we have, if you go to dashboard.chia.net, this is our public dashboard. I think we have over about 130,000 Chia farmers today all over the globe. And the reason that we have so many, and this we believe that we are the most decentralized cryptocurrency in the world. I don't have any evidence that any other crypto is bigger. Bitcoin has at its peak had like 60,000 or something like that. At our peak, we had like 450,000 nodes or something like that in 2021. So the whole reason why this is not just an accident, this is one, good engineering on the full node part. We have like really dialed in the database and IO requirements for actually running this fully peer-to-peer node. It runs on something like a Raspberry Pi or a single CPU VM. It's like nothing, right? And the only thing you need to join the Chia network is 100 gigabytes of space for a single plot file, and you can start farming. So if anybody has any spare storage space, they can turn that into earning money by utilizing that spare storage space and putting it up to the Chia network. So the reason why we have so many farmers is there is actually a financial incentive for them to run these nodes. They actually get paid today about 50 to 60 cents per terabyte per month, which may not sound like a lot, but when you can buy a used hard drive for $5 or $6 a terabyte, you're effectively paying that storage off in like 10 to 12 months. That's actually a decent deal. So
yeah. You mentioned earlier about the IDC reports that show underutilization being a significant component of storage that exists out there today. And I'll take that as a given. I mean, that's certainly feasible. Do you see something like Chia being a way to take advantage of that underutilization in the enterprise? Let's say, if you have, I don't know, a petabyte or two sitting in your enterprise, in which you're only using maybe, let's say, 3/4 of that, and you got like 250 terabytes sitting around
yeah,
someplace. I mean, do you expect somebody to go fill that with Chia plots, I guess?
The at traditional enterprises, it may be a little bit tougher, but there are some companies that are taking advantage of this. I was just at CES on a panel for the Blockchain Association, and there's a fellow there from Crusoe Energy Systems in Denver, and they do like this flared gas Bitcoin mining, and then they have this like GPU cluster, for rendering. But when they're not using that cluster for like AI use cases, they're doing crypto stuff in the background. And so we've seen that with Chia, right, where people have like these assets that are used for like AI or other, and they have a bunch of storage. And then when they're not using it, like the customer goes away, they can flip that over to these other crypto. And Chia is a great opportunity for that, where they can say, okay, we have extra storage. We can put it up to the network for a little bit, and then a couple months later, okay, we have to erase a little bit of it for to this customer workloads. They can reclaim that space as needed. But this is a really tremendous way to basically leverage that extra space and basically pay for itself over time.
I had a friend of mine that as he was they would buy storage ahead of when they actually needed it, and they would plot on the storage until they actually started to use the storage, and using that as sort of a Chia framework and things of that nature.
Exactly, and with the way we have it set up, there's no user data. You're not storing anybody else's files or anything weird, so there's not really, once you understand the protocol, you'd understand there's not really any security concerns by doing this. Like, it's completely fine.
So I remember there was a story that kind of got some traction where Backblaze did a analysis to decide whether they wanted to do that, basically plot Chia ahead of user data on their systems.
Cloud
and I was
storage,
surprised
yeah.
at their conclusion to not do it. And I'm wondering if they're going to revisit that in light of recent developments, being able to create plots a lot faster in the
We'll
new
just say it was
GPU
much
regime.
more challenging. The software in 2021 wasn't very mature for these generating plots, and that's something that's 2 years of innovation has come. Used to, I know people were worried about like wearing out their consumer type SSDs by Chia plotting, and there was all this there was like this gold rush in 2021 where everybody's trying to get in and nobody really knew what they were doing. Now you can do this completely in memory and it's super fast, and so it's the barrier of entry is, especially for somebody who has a lot of resources like a larger company, it's much easier than it was in 2021. I don't know if you guys remember this, but I did actually speak with Backblaze after that. They interviewed me. We had a great interview. It was just but their scenario was like other companies. There was a lot of uncertainty in just the crypto market, and at that point, the Chia net space was just growing exponentially like crazy. And we're like, okay, when will this ever stop? But the biggest challenge is that in these and this is the same reason why you can't farm Chia on AWS, S3, or Dropbox or any of these services, is because they replicate the data. And in some of the more sophisticated storage systems where they're using colder storage, they're erasure coding it, and or in many of these systems, there's just straight up a mirror replication. And when you're doing something like Chia, that storage now has to compete with somebody else who's not doing that, not using any redundancy, not using RAID, not using erasure code, and they have a better TCO. And so the economics are never going to work out unless you actually, strategically orient the storage software, to basically not use all this replication and overhead. And there's ways to do that, where you could have a shim file system layer or something, where a fuse layer where the plots are underneath the actual real user data and some other stuff. But we've seen a couple interesting. So somebody wrote their own file system for plots. Like Chia. There's all kinds of crazy stuff the community has written. It's like
Okay,
mind-blowing.
you've nerd sniped me now. What's the what is this shim file system that I can use to put on top to basically have underneath my user data? So it seems like Chia is like dying for a hybrid file system that has the notion of like a nice to have data class that you can then
could
just
be gotten rid
overwrite
of
as
occasionally.
needed. It's like, so storage since its invention has always been about like trying to
keeping bits,
like trying not to overwrite data
right.
as hard as
Yeah,
possible.
it's a totally new paradigm, and that's funny for a lot of like real storage guys that get into Chia. They're like, I tell them like, no, you like throw reliability out the door. Like it doesn't matter. Like an uncorrectable bit error rate of 10 to the minus 12, like perfectly fine for Chia. Like it's just random data. They're like, like, and I'm like, don't raid your drives together. They're like, but what if one fails? You're like, don't worry about it. You're not losing any user data. You just recycle the drive and move along your merry way. Yeah, so it is a different mindset of thinking about this new type of data, but it's also tremendously fun for storage folks, because it is like somebody talked, mentioned something about Chia farming, like being analogous to like Sudoku for a sysadmin. You're like, you're creating these data files and moving them around. Like I have scripts that are moving hundreds of terabytes of storage a day right now for my Chia plots, and it's just super fun, like architecting these bottlenecks and interface buses across network and storage, and like actually seeing how fast you can move these plots across the systems. It's super fun.
Yeah, I understand to some extent why you wouldn't, do something like Chia plots and then archive them off the tape or something like that, and then bring them in. If you had a tape library or something like that, bring them in on demand as needed or something like that.
Yeah,
That's
it's
a
funny.
whole different question.
We specifically set the protocol up so that tape wouldn't work. If somebody can do a random read on tape under 30 seconds, then they're golden. But
Yeah, but the whole LTO tape and stuff
Yeah,
like that, you can
I
do it
think
quite a
I
lot
think it's
under
a couple.
30 seconds, but it has to be mounted.
Yep.
That's the
So
challenge.
yeah, that's yeah. It's funny. The workload looks very much like it's like an archive type drive. It's similar to what an archive hard drive would be at like a hyperscaler, but
Yeah, like half IOP kind of thing. Yeah, it's
yeah,
it's
it is
it's
just
an
being.
archive type of world, right?
Yeah, the only difference is access. The drive is getting accessed every 30 seconds or something, which on an SSD is totally fine. The drive just goes to sleep and wakes up to do the IOs, goes right back to sleep. And modern SSDs are like 5 milliwatt active idle in this state. Hard drives, it's a little bit too frequent for the hard drive to spin down, but they can do some of the things where like the hard drive goes into this idle state called idle B, where it parks the head. You can do stuff like that, but you got to tune some of this. But
Still
yeah,
moving.
it's
You're still
pretty well
moving
understood
ladders
workload.
and stuff. You're still doing a lot energy
Yeah.
wise, even though heads are part.
Yeah, the big difference is, you have a hard drive that's 5 watts, comparing that to like a Bitcoin miner at like 3,500 watts.
Oh yeah, that's true. That's
Yeah,
true.
it's a
That's true.
little bit different.
Huh. I think there must be an opportunity here for trying to figure out how to use tape with Chia, but that's a different discussion.
Well, there's a great financial incentive. Anybody who wants to try can get some farming rewards. So, this is the beauty of these open decentralized systems, which is, if you have the right incentives, and then the network automatically figures out what the right market economics are and the right optimal solution. Um,
So you mentioned earlier that over the course of the last couple of years, Chia has matured as far as a crypto capabilities perspective. When you're talking like smart contracts and things of that nature, is that what you're
oh
saying?
yeah,
Or
yeah. So going back to all the stuff I live in the world of storage because I'm our storage guy, right? That's just my job. Like I work with our main partners. You can imagine this is like Western Digital, Seagate, Micron, a bunch of there's I
my kind of
mentioned we're all working.
friends? These are all
Yeah,
my
we're working on
friends.
this. Yeah, and I'm a big part of SNIA and OCP and IEEE and all that stuff. But like the real use of the blockchain is the actual use case. And so in Chia we have these things called smart coins. They're and it basically allows us to do anything you can think of to program into the coins. And so what we've done for Chia is actually release these as primitives so that other companies can actually bake these into their software suites. So the first one we have is called offers and Chia asset tokens. So basically, you can tokenize anything in the world. Now, you could tokenize. One of the things we're working on is tokenizing real world assets and commodities like carbon credits. But you could do a stock. Anything you can think of, you can turn into a token. And then we have these offers, which are completely decentralized peer-to-peer trading of those assets. And so, what I could do is make an offer for this decentralized asset, post it on an exchange, and it's done in a way where there's no counterparty risk. Like there is no risk of me losing that asset. I'm just signing half the transaction, saying, "Hey, I'm willing to trade this asset for this other asset." And somebody on the other side of the world can say, "Oh, I like this. I'm going to take that trade," and then they can complete that on chain. So this is full decentralized peer-to-peer trading, and this has never existed before Chia. And it's almost mind-blowing to think about. This is taking any markets and adding real liquidity and depth and the ability to do this trading. It creates these market makers and all kinds of decentralized exchange, all kinds of really cool tech. Yeah,
That's
that's kind
bizarre.
of like so that's the first one. And we have on top of that we have an NFT standard, and there's a lot of people that do this type of trading for NFTs, and it's just like fun art, where it's nothing like super high value. The one we did as a reference platform for the NFTs was called Chia Friends, and we're donating all the proceeds of that to charity, to the Marmot Recovery Foundation, which it's like a kind of funny thing because we have like marmots as the meme in Chia. So
I see. Well, that's nice. That's
listen,
nice.
yeah, and that's kind of the first big area of
So, so
blockchain.
I mean, a lot of the other blockchains have, I don't know, almost languages for their smart contracts and things of that nature. You're not offering that in Chia, or you have that as
Yeah,
well?
yeah. So yeah, our smart coins are in this language that we invented from the grounds up called Chia Lisp, and it's a
Chia
Lisp.
Lisp?
It's a
Okay.
Lisp-like program language.
Yeah,
Yeah,
yeah, yeah,
yeah. You
yeah.
probably know Lisp. Yeah.
Yeah.
So yeah, it turns out this functional language works incredibly well for smart contracts because what we care about more than anything is security, right? You can't have banks and financial organizations and using a smart contract that's going to be hacked and not secure, and so you have to be able to audit these things and know that they're working properly. So we have this. Like again, I'm our storage guy, but Chia will likely be most famous for this Chia Lisp and programming environment. It's so much so that the Bitcoin folks have already been starting to take parts of it and include it into some of the Bitcoin protocol because it's quite frankly is much better than what they have. And so one of the there's all kinds of interesting stuff you can do in this Chia Lisp. I mentioned it's Turing complete language, so anything you can think of that governs the money, any single possibly you can think of, you can do. Now in Chia, like in Linux, everything's a file. In Chia, everything's a coin, and the rules that you program into the coins are like who can spend this coin. Is there a weight limit before you can spend it? We have something called a clawback, right? Which is like, okay, if you spend this coin, it goes into this escrow period for a certain amount of time. And if a wallet wants to claw back and reverse that transaction within that escrow period, you can. And so this prevents stuff like sending money to the wrong address, or if somebody hacks you, you can try to go rekey your wallet and then do a clawback of the money so that now the attacker can't have your money because it goes to so there's this whole suite of applications of coin security stuff that we call custody. Now, custody is just like, okay, you're in crypto, you are your own bank. You are the bank. You are self-custodying the money. And so in Chia, we're allowing now a bunch of better functionality. Our CEO likes to say, we want to be, crypto needs to be easier to use than cash and much harder to steal. And smart coins and contracts have this like ability to do that. You can program all these really cool things into the money that allow you to have much more security, much more control. So we're going to have these custody vaults for Chia that you can have different classes of wallets, like a cold wallet that you have lots of money in that's super secure, warmer wallets that are you're using for more day-to-day transactions and stuff, hot wallet that you maybe use on your phone with state channels or small payments. And you have all these different classes of wallets and custody with different security locks. The other thing you can do with these things is tie them to DIDs or digital identifiers, where you can say you have you want to delegate your trust out to 5 different friends, and say you lost your wallet. Like today, if you lose your Bitcoin seed, like there's no getting that back. You just lost all your money forever. Like there's no call the Bitcoin guy and get your money back. But in Chia, we could actually have a way where you could delegate out to a certain number of people and say, okay, if 4 or 5 of those people got together and put their keys together, they could recover my wallet and create a new key and claw back that money into a new wallet.
Nice. It's a nice feature. So
Oh,
I reading, watching the video that you had and stuff like that. There's these things called harvesters, and then there's nodes and there's farmers. I understand farmers are plotting and saving the plot files on their storage. I understand the node is actually, I'll say, maintaining the state of the blockchain. If that's correct, I'm not sure that's correct, but it's as close as I can come to. Go ahead.
Oh yeah, I was gonna say, yeah, I would before we go there, just while we're on that topic of the blockchain use cases, just before I forget, we have one more major product called Data Layer, which is basically a federated database, but we track it on chain, and so you can allow for a decentralized database to have like auditability and transparency of a public blockchain. So the first real world use case of this Data Layer product that we have is our largest today. It's at the World Bank for something called the Climate Action Data Trust, where they're actually using this technology on the blockchain to track the registry of all the carbon credits in the world. And there's countries like Singapore and others that are like actually using this for real registries to track these carbon credits. But this is just another application where blockchains can kind of give this transparency, auditability, visibility into the real world, where now you can have a bunch of parties that don't really trust each other, have data, and know that it's they're coming from the right place.
So if I'm like an industry and I'm burning carbon left and right and stuff like that, and I want to actually spend some money and buy some carbon credits to offset that carbon activity, I can use this data layer.
That's where they'll all be tracked now. If you go to this Climate Action Data Trust website, you'll see that they're going to have this registry of data, and any project that's a real carbon project will be in that registry. And so today there's a lot of shady stuff, or somebody's like buys these carbon credits, but they're like, turns out that they weren't real, or from a company that's already retired them, or whatever. Now you can go on the blockchain and be like, oh, this came from this registry, and it went to this country, and this is the person that bought it, and here's when they were retired. All this happens on chain. And so you can trace it back and actually replay it back. The best part about this is it's any one of these 130,000 public Chia farmers that are running a node can just turn this on and validate the data themselves too. They don't have to trust, that the data's coming from. This whole point is it's all on chain, so you can see, who signed what commits and or monitoring the stuff in the database.
No, let's get back. So, and they're effectively using Chia's federated database data layer to do this, but anybody could use this Chia federated database data layer to do other stuff, right? If I want to do Napster or something like that,
it's just an amazing. Yeah, and remember, this data isn't stored on chain. The data is stored off chain, but the hash of the data is stored on chain and tracked. And so you could publish data layers for all kinds of really interesting stuff. And we're going to see some really cool use cases. But think about it, it's just a distributed key value store that now you can audit and transparently look at the records of who updated what when by anybody on the chain whenever you want. The applications for this are just mind blowing. Like, people have already come up with just crazy stuff.
Yeah, this is bizarre. I mean, so the storage is actually off chain, but the key and the hash are sitting on chain, is what you're saying.
You got it. Yeah, it's all tracked through this this data layer thing that we actually have built into the whole, like actual whole client and everything. So yeah, it's very, very slick. Anybody who wants to make a public public blockchain app, this is something that you can easily integrate in.
So I was going to kind of steer us there. So is that an example of Chia actually going towards storage, decentralized storage as a service, or enabling decentralized storage? I know that there's other projects out there that they want to be the the decentralized Amazon S3 or whatever.
Yeah.
But is data layer something that could in the future enable those kinds of services?
Yeah, well, it's even like somebody could make their own service and then tie it back to data layer. So Chia doesn't have to like host this themselves. They could just make their own product and use this as that reporting. Taking Merkle tree hashes of data to making, for like if you're doing a backup or something, that they could validate that it is the right data and that nobody tampered with it. But we're not going to go compete with Filecoin or anything. We think that these actually, I work with a lot of these guys like Filecoin and Storage and all these decentralized storage companies that are actually providing a real storage service. But you're competing with AWS. It's like it's going to be a hard
Backblaze,
time.
Wasabi, those kinds of guys.
Yeah. No, the interesting thing, which I think is surprising, so the Filecoin right now is more of like an archive use case, but like the prices, if I'm reading the prices correctly, it's like 10 times less than S3. Like, so for storing archive data, it's seems reasonable for, especially if, now you're going to trust your company on this stuff for like these crypto decentralized storage stuff. Maybe not, but
performance is the other side. Reliability.
Certainly at 10x lower price than AWS. Now you start thinking like, okay, we should at least test it or look at it.
Yeah, we can start playing with it, stuff like that.
It seems to me that like if you're someone who's responsible for a lot of storage and it's connected to the internet, you can sort of weigh these different options, and Chia sets the floor on what the value of online disk storage space should be, right? And then anyone willing to pay an incremental amount higher than that, like you would delete your Chia plots, and then it would be cool to have like a fluid system that could arbitrage that market. I know that your real sensitive workloads aren't gonna trust their data to these 5+ year old Chia drives or whatever.
Yeah.
But I think it's an interesting thought, or I think since Chia's like already attracting all of these storage minded folks to the ecosystem, anything that combines the opportunity to leverage that storage in other ways is going to be interesting to them.
Yeah.
Just like the we're starting to finally see, like 10 years ago people talked about AI, but now we're seeing it like for real. You're seeing Stable Diffusion, art like gene generated on the fly from a scribble that looks like a beautiful picture. You're seeing ChatGPT in that same sense of like, people had this idea for a long time, which is there's all this underutilized resources just sitting out there and doing nothing. And there hasn't been the right financial incentives and capability to actually use those for real customer workloads. We're starting to see that now. I'm seeing a bunch of new services that are able to take idle GPUs and instead of using them for some stupid crypto mining, use them for AI workloads. This is a perfect thing to offload for training because it isn't mission critical data. It is ephemeral data. You can just get a bunch of GPUs from a bunch of different people and throw out a bunch of different distributed workloads. These workloads are distributed by nature. We're finally starting to see some of this come together, and it's been just amazing to see how much progress the industry's made just in the last like couple of months. I've seen a bunch of new projects doing this, and it's all this AI has sparked all this interest again of getting this idea of like using underutilized assets, earning revenue from them, for instead of having to pay AWS and all these guys that are hoarding all the A100s.
Right.
Yeah. I think for those reasons that you'll find that there's a very long tail of value to be exploited in all these resources that are floating around out there. And if you can be the one to unlock it, there's a lot of potential there.
All right, gents. So Mike, any last questions for Jonmichael before we leave?
I do, but I'm going to take them offline because they're really specific and ultra nerdy. So,
All right, Jonmichael, anything you'd like to
Oh,
say to our listening audience before we close?
oh yeah, I try to stay high level because I know, I know a lot of the storage folks are not like super into crypto, but I just tell you, like, take a look. Chia's really awesome project, and it's not like typical. I know people hear crypto and think like scams and Ponzi's and all this stuff, but it really couldn't be any farther than the truth in that. It's just, yeah, we have so much real value in unlocking and this decentralized money and financial use cases, and there's so much cool stuff going on in the ecosystem. But for mostly, if you're a storage nerd, like, you should check out Chia
We
Farmies
all
because
are.
it's super fun. Like, there's just making these plot files, moving them around, and seeing how this whole system works. You had a question about how all this harvesters and farmers, and we have all this stuff in the protocol about how all this stuff works, and yeah, it's just cool to geek out on and play with. So if you're into storage, just check it out. I know many people probably took a look at Chia like 2 years ago during this crazy run up, and like, the software has matured a lot since then. It's
Yeah,
been two
yeah.
years of hardening in this open source system. So yeah, take a look. It's much better, much easier than it was back then. So
Okay. Well, that's it for now. Bye, Jonmichael. Bye,
thank you guys so
bye,
much. Yeah.
Mike, and bye, Ray. Thanks again for being on our show today, Jonmichael.